Hey, geometry students. We start out chapter 9 with translations. And so chapter 9 is all about what are known as transformations. We have four major transformations. We have translations, which obviously we'll be covering today in lesson 1. We also have reflections. And we have rotations. And then the final one is dilations. And so we spoke about each of these at the end of class last time. So we'll just sum these up. And translations are like a shift. Okay, you just take an original thing and you shift it up, down, left, right until it's in a different location. You have reflections, and so these are over a line of reflection. And so if you had some sort of shape like this, you flip it over, and it's the reflected image. You have a rotation, that's like tetherball. You have a center of rotation, and things just kind of rotate around it. And then you have dilations, which is the one that's a little bit different. And a dilation, you have a center of dilation, and based on that center, you're essentially drawing similar figures using scale factor. So you have three of these where you are doing something and they stay the same. Translations, reflections, rotations are what are called isometries. Isometries are transformations where the image is congruent to the pre-image. So what does all of this mean? Well, essentially, what are these terms? What is the image? What is the pre-image? The image is the new shape. So if this was the original, then this would be the image. If this was the original, then this would be the image. Original, image. Original on the inside, then this would be the image. It's the new shape. And so if we think of the image as the new shape, then the pre-image, the thing before I transformed it, that would be considered the original. So pre-image, image. Pre-image, image. Pre-image, image. And we have some notation. And so like if I had an original point, the pre-image, we'll call that A, well, then the image would be A prime. And you have this little dash mark here. And again, the way that we would say this, we would say A prime, indicating it was the new thing. All right, well, when it comes to translations, translations are the first of the transformations, and we've got some new, I guess, notation that we're going to have to get used to, and but ultimately it just still goes back to the fact that it's just a shift. It's how much does it go left, right, up, down, and so we'll write down kind of like it's a shift. And the notation that we're going to be using is going to be when we want a translation, we're going to put capital T, and then down here in pointy brackets, you're going to have how much you want it to go up and how much you want it to go right or down and left. And so this number will tell you how far to make it go left and right. If it's positive, it's going right. If it's negative, it's going left. And then this number here would tell you how much it's going up and down. If it's positive, it's going up. If it's negative, it's going down. So if I had a translation, say, of 3, -1, this means I would take the original point. So say the original point is here at -2, 1. Well, this is a translation of 3 to the right and 1 down. And so I would go 1, 2, 3 to the right and 1 down. So if this was my pre-image, the original, then this would be the image after it had been translated. And we can do this with points, we can do it with lines, we can do it with shapes, all sorts of things. All right, to some examples. This one says, what is the pre-image, or what is the original of A prime at 4, 7 if there was a translation of 2, -5? All right, so this is what happened after the translation. So I want, what is the original? So A, just regular A, not A prime. Well, instead of adding 2 and subtracting 5, because we want to go backwards, we would actually subtract 2 and add 5, if you could get your mind around that. And so 4 minus 2 is 2, and 7 plus 5 would be 12. And you can see that if I applied this translation, add 2, subtract 5, add 2, subtract 5, you would get your image of A prime if we did that. And so that's kind of one thing to think about. All right, next one. Actually graphing some stuff. Here is the pre-image triangle RST. We want to graph the image, and we have a translation of -3, 4. So we're just going to take each one of these points and shift them 3 to the left, because that's negative, and then 4 up. So 1, 2, 3 to the left, 1, 2, 3, 4 up, and we'll call this R prime. Don't forget to label everything. 1, 2, 3 to the left, 1, 2, 3, 4 up. Call this S prime. And then the one down here, 1, 2, 3 to the left, 1, 2, 3, 4 up. We'll call this T prime. And we'll connect our dots. And you can see that this is an isometry. These triangles are congruent. All right. Here we are writing a rule that describes the translation between these two things. So remember how we do that. We just say big capital T and then in pointy brackets down here. Well, the one thing that we got to be careful of is a lot of times, you're used to reading left to right. So you might think, all right, 1, 2, 3, 4, 5, 6 to the right, 3 up. Except, remember that this is the original and this is the image. This is the pre-image, this is the image. And so, in fact, well, it's actually happening. We're starting here and we're going 1, 2, 3, 4, 5, 6 to the left. So I have -6. And then 3 down, so -3. So be careful. Which ones are your originals, which ones are your pre-image, and which ones are your image? Be looking for those signs to be able to tell which one you start with. Okay, this one, prove that this translation is an isometry. So this is learning target number 2. And so there aren't a whole lot of examples of this in the book. So you can kind of just practice this one to get a handle of it. So here is our pre-image. Here is our image. Notice that we have triangles. Well, how can you prove that triangles are congruent? Well, one way that you can prove that they're congruent is using SSS. And while all we have here are some triangles on a grid, we don't actually have any markings like we traditionally do. We can still prove this using SSS if we know the distance. Well, we can say that RT would be congruent to R prime T prime because both of these are 2. We can just count those. All right, so we've got one side, we've got S. Let's do the next easy one. We can say that TS is congruent to T prime S prime, and these are both equal to 1, 2, 3, 4. And then, well, the next one, not as easy to see. We can always use the distance formula or the Pythagorean theorem. We'd say 2 squared, 4 squared. So 2 squared plus 4 squared equals c squared. So we'd have 4 plus 16 equals c squared. C squared would be equal to 20. And so c would be equal to the square root of 20, and as an exact square root, be 4 and 5. Square root of 4 is 2. Square root of 5 is that. So our final thing, we could just say RS is congruent to R prime S prime, which is equal to 2 radical 5. And then we'll finish this off and we'll just say, therefore, by SSS, this translation is an isometry. All right, that's it for lesson 1. So learning target 1, go ahead and practice these. And then learning target 2, just kind of repeat the one that we just did. If you want to come up with your own triangles, you can certainly do that for extra practice.